Hello everyone. All right, so today we're going to look at the fundamental theorem of algebra and expressing polynomials as a product of linear factors. Now, a lot of the information that's here, I know this first page looks like a lot of notes. A lot of it is stuff we've already talked about and we've already figured out, and now we're just organizing it and putting it in one place, okay? So let's go through some of the things that we know, and some of this we have talked about already before. So the fundamental theorem of algebra is really fundamental. It's the basics of all algebra. It's the building blocks. It's the cornerstone of algebra. And that rule says that every polynomial of degree greater than 0, so at first degree, second degree, third degree, has at least one zero or root, but it's possible that you have an imaginary root. Okay, it doesn't have to be a real root. Now, I know we said that's fundamental and the cornerstone of all algebra, but even more powerful is this corollary. Now, a corollary is a theorem that comes from another theorem. And this is a more specific theorem that says a polynomial function of degree n has exactly n roots or zeros. So in other words, a third degree polynomial has 3 roots. A 10th degree polynomial has 10 roots. Now there's another theorem that says every polynomial of degree n greater than 0, okay, so it's not the constant polynomial, all the others, can be written as a product of a constant k. That means if there's a greatest common factor, like 2 or 3, you can factor that constant out, and n linear factors. In other words, every polynomial can be factored, okay? So the k is just a greatest common factor that you factor out, and then it's x minus a root times x minus a root times x minus a root till you run out of roots. So this r1, r2, r3, all the way down to rn, those are just the n roots of the polynomial, and the subscripts are just counting how many roots there are, okay? So it's just any GCF and then x minus a root times x minus a root times x minus a root. Now, a couple of notes that are really important to know. So we know that every integral rational equation of degree n has exactly n roots. Okay, 10th degree has 10 roots. If a root occurs more than once, say k times, this is a root of multiplicity. Okay, so if the root occurs 3 times, it's a root of multiplicity 3. If when you factor it, you get that answer twice, it's a root of multiplicity 2. Now, roots can either be real or complex. Now remember, your real roots, those can be rational or irrational. And that's going to come into play in a little while too. That'll change things a little bit. So now, if the polynomial equation f of x equals 0 with rational coefficients has a root of the form a plus the square root of b, in other words, it's an irrational root, where a and b are real numbers, and b is a positive number, but not a perfect square, then the conjugate a minus radical b has to be a root. Irrational roots always come in pairs, because remember, you got those roots not by factoring, but by using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you get one irrational root, you have to have 2. And those are not the only kinds of roots you find from the quadratic formula. You can also find a complex or imaginary root, a plus bi. If that's a root, then so is its conjugate, a minus bi. So it's important to remember that both irrational and imaginary or complex roots always come as conjugate pairs. All right, and just a couple of things to remember. Remember, the multiplicity of a root is the number of times a 0 is a root, so a multiplicity of 3 means the root happens 3 times. If the multiplicity is even, the graph will bounce off the x-axis. It's tangent to the x-axis at that x-intercept, right? If the multiplicity of the 0 is odd, it's a root of multiplicity 3 or a root of multiplicity 5, it's going to cross the x-axis at that intercept. And if it's a root of multiplicity 1, it's not going to change concavity, but if it's a root of multiplicity 3, it's going to change concavity when it crosses. Okay, so now we're going to look at two different problems. The first one is f of x is x cubed minus 2x squared minus 5x plus 6. And for each of these, we're going to determine the number of roots, we're going to sketch the graph, we're going to find the roots, and then we're going to write the polynomial as a product of linear factors. So, if we have this f of x is x cubed minus 2x squared minus 5x plus 6, the highest power of x is 3, which means we're going to have 3 roots. Now we're going to go to our calculator, we're going to graph it, and we're going to plot the points. Okay, so here we are in the calculator. We're going to add a graph page. Our function is x cubed, so x raised to the third, get out of your exponent, minus 2x squared minus 5x plus 6. Hit enter. You want to change that window, menu, window zoom, window settings. Our x's are going from negative 5 tab to 5 tab, count by ones. Our y's tab are going from negative 6 tab to 10 and tab it. We are counting by ones again, so we hit enter and OK. And there we go. We have our graph. We see what it looks like. We can hit Control T so we can plot points. We also, I'm going to hit Control T to turn that off. We might want to locate our max and min. So I'm going to analyze graph. I'm going to find the max over here first. Now I know what to plot. I'm going to menu, analyze graph. I'm going to find the minimum over here. Now I know what to plot. If you're not sure what your x-intercepts are, you can tab f of x equals 0 and hit enter. Go to menu, geometry, points and lines, intersection points. Click on the graph of the function, click on the x-axis, escape to exit out. If you need to move things so that you can read them, that's okay. I'm going to move my F there, and now we have our roots. Awesome. So make sure when you graph your polynomial that you have the arrows, that you've actually plotted points, and we should have seen from our calculator that our roots are at these 3 x-intercepts, which are at x equals negative 2, 1, and 3. Now that we know what our roots are, we can factor f of x, and notice we needed 3 roots. We've got 3 different ones. We're going to say x minus the root negative 2, but when you minus a negative 2, it becomes plus, times x minus the root 1 times x minus the root 3. Who thought factoring a cubic was going to be so easy? You used to hate factoring, right? That was nice and easy. Let's try one more. So now we have a 4th degree polynomial, x to the 4th plus 4x cubed minus 3x squared minus 18x, which means we need 4 roots. So go grab your calculator, graph your function, plot points, put arrows, all that wonderful stuff. I'm going to add a new page. It's another calculator page. My function this time is x raised to the 4th, get out of my exponent, plus 4x raised to the 3rd, get out of my exponent, minus 3x squared, minus 18x, hit enter. We need to adjust that window, menu, window zoom, window settings. Our x's are going from negative 5 tab to 5 tab. We're counting by ones, tab. Now our y's are going from negative 20 tab, up to 14, tab, and we're counting by twos. Now I'm going to tab and click OK. Now we can see our graph, but in order to graph that nicely, we need to menu, analyze graph. I need a minimum over here. I need a menu, analyze graph. I need a maximum over here. I need a menu, analyze graph. I need another minimum over here. We might want to go to that f of x and put f of x equals 0 in here. Menu, geometry, points and lines, intersection, click on your function, click on the x-axis, hit escape. Notice we got the point -3, 0 twice. That's because it's both a minimum and a root. Okay, and we should have seen on our calculator that our roots are at -3, 0, and 2. However, you should also notice that there is a place where the graph is tangent to the x-axis, which means that that root -3 is a root of multiplicity 2. Which means when we now factor this polynomial, it's x minus the root -3, which becomes +3, but we have to square this. And then we have x minus 0, which I'm going to talk about in a second, and then x minus 2. Now, we know that x minus 0 is just x. We are never going to leave x minus 0 as a factor. You're going to write that as x, and you're going to put it in the front, so it's in standard form. F of x is x, and then we have x plus 3, quantity squared, times the quantity x minus 2. And this is the proper way to factor that quartic. Not so bad for a 4th degree polynomial to factor. All right, so this is where we're going to end today. So we summed up a lot of our notes. Every polynomial of degree n has n roots, and every polynomial can be factored. Awesome. Have a great day, and I'll see you soon. Bye.